Here we go, talking about simple statistics in this presentation. Some of the things I have already mentioned, and many of them you may already be familiar with, but here we go. I thought, well, maybe this will cheer us up to take a look at things that are fun related to statistics and probabilities and so on. But let's get to the meat of it. Often in articles that you read, they're going to present what they call descriptive statistics. And these are the results in very simple form. Oftentimes they'll talk about box as we do this. Now let's go to tests of significance. We're always trying to reject the null hypothesis. The null hypothesis usually is there is no relationship between the independent and dependent variable, and the test that we run will allow us to determine rejecting the null of no significant difference. Now let's go to types of populations that are tested. For a non-parametric test, you don't assume there's a normal distribution of data, and that's one way to do that is with chi-square statistic. This is a very low level test that may be the only thing you can do depending on what kind of data you have. Now, a parametric test does assume that there's a normal distribution within a population, and here you might be using other tests that we commonly run across in the kinds of articles, especially that I picked out for you to take a look at. These are t-tests, Another way to present information is by percentages. And obviously this is a low-level way of looking at the world. So if you have 100 people and 65 of them say they do some activity, that's so here's something I found online related to high school seniors who have consumed 5 or more drinks on an occasion within the previous 2 weeks. And here they're doing it as a timeline. There's a little problem with how this table is developed because 1980 to 1990 to 2000, it's like they're using these equal distances, and then it goes to 03 to 06, and you really should crunch those together so they're making it look bigger than it is. And also, if you can see in the lower left hand corner, that kind of little squiggle means they're cutting out from the low percentages, which also changes the look of the table. But regardless, we've got percentage of students on one side, and then we have years. So we can see in 1980, 41.2% indicated within 2 weeks they had 5 or more drinks, versus in 06, only 25.4%. And I would imagine there's a significant difference between Now I'm showing you here a screenshot of asking for the computer to run a cross tabulation. All a cross tabulation is taking a look at the data, rows and columns. Here you have one question. If you look at under current results, it says, which of the following do you expect to purchase in the next 12 months? And you can see all these choices. This is probably somebody's pesky survey they asked folks to fill out online. So you have across the row is what is your age, from 15 and under through I guess between 45 and death is the last category. They don't care about you so much after that. And how many people frequencies just mean how many times something appears. So the slide that you just saw that had percentages for, let's say, So like I just talked about with that table we saw that had 15 and under with empty cells, if you have empty cells, you will get a significant chi-square. But it doesn't matter, which is why I'm saying the cross tabulations, it can be a problem. So maybe you had better rethink your categories, or maybe combine categories so that you have people in all the cells, counts within all the cells, or you get non-significant significance. Why you would use chi-square, because it's not the favorite by any means, is if your now here's an example of a table where, again, we've got, it's from that same survey, we've got these 15 and unders, where those 8 people are all students, so no one's in that square. In the 16 and 18, no one is a part-time student, so no one's in that cell, and so on. So because of that, you're going to get significant here, this is off of one of the papers I did looking at injection drug users in St. Petersburg, Russia. And I split the data by folks who indicated on a survey that they were HIV positive and those who indicated they were HIV negative. Now you can see there's far more who self-reported that they did not have HIV than those that did. But I was interested in what are some possible significant differences between those groups. So if you look at the p-value on the right-hand side, by age category, there was no significant difference. And you can also see I put both the percentage and the actual number, which is in parentheses. But gender-wise, I think we find that it's much more likely that it was males who self-reported that they were HIV positive than females. So of that sample, 81.3% of the HIV positive self-report individuals they were male. And look again at the chi-square statistic. You can see it's less than 1 for the non-significant first statistic by age, and 6.4 chi-square result for the significant. So again, as it goes up, it's more likely that you have a significant p-level. Let's talk about what are correlations. I always think of them as associations. You can have correlations as far as running the statistic with interval level data or ratio level data. Now obviously this isn't communication focused, but if you took a look at one's caloric intake and changes in body weight, let's say over a period of time, you would be looking at correlation, meaning probably the higher the caloric intake, the greater likelihood that one's body weight will increase, or vice versa over some time frame. In our literature in communication and social science, they usually use the Pearson product moment correlation. That's what they'll call it, Pearson R. R is the statistic used. That's the symbol for correlation, is an R. So get used to seeing that in the literature. R equals. The only possibility for correlations are that they are from -1 to +1. So R equals somewhere in there. If something was a -1, that means there is a perfect inverse correlation. Perfect. As something goes up, something else goes down. That's an inverse correlation. Or it might be called a negative correlation. As something goes up, something goes. Now when you have a large database, large number of people, it's pretty easy to get statistical significance with correlations. So your task is you need to look at the R, the correlation statistic, to see is it really an important result. And the general rule is if the R statistic is 0.40 and above, up to 1.0, or -0.4 and lower, all the way to a -1.0, that is what we want to look at. Again, it's easy to get the computer to say you have significant correlations, but they can be really. Now, if you graphed it out, this is what a positive correlation looks like. If you took all the results and stuck them on a graph, in general, you'll see this slope in this direction. So as something goes up, the other goes up. I guess not perfect. You can see there's little crosses or marks here that don't quite fall, but that's human behavior. That's fine. A negative or an inverse correlation looks like this. And here the actual R is a negative 0.74. And remember, anything with a negative 0.4 and lower is socially significant. And here we're looking at what one receives as a grade, I'll say on a test, and the number of beers somebody drinks. So the inverse relationship is the higher the grade, the fewer beers consumed. And it can be stated in another way, the lower the grade, the greater the number of beers consumed. It's a negative correlation. As something goes up, something else goes down, or vice versa. Here's another chart to look at that I thought was pretty clear on the, laying out the correlation coefficients. And they were taking a look at a variety of, we say this a lot, psychosocial variables or factors, and male marijuana use. And probably most of these would be statistically significant, but not socially significant. You can see on the negative side with negative 0.4, the closest is just shy of that, and the measure is, I think, intolerance to deviance. So even that, which would be significant, isn't socially significant. But positive correlations, there's several that are at 0.4 or higher, and that's relationship between, again, it's male marijuana use, and if friends drink, positive correlation, that's socially significant. If friends pressure someone to use marijuana, if friends use marijuana, I think individuals' deviant behavior, alcohol consumption, and other drug use, all those have a positive correlation. As those go up, so does male marijuana use, or as those go down, male marijuana use declines. And those are socially significant correlations. I just wanted to throw out a few hypotheses that are correlational. So, parents' weekly number of hours of TV viewing, it might be stated this way, will be inversely related to the number of times TV ratings are used to guide children's viewing. So the more parents watch TV, the less likely they are to use TV ratings guide for their kids. So it's a t-test. Next step, it means you are looking at a comparison of means or averages. What you're looking at are 2 cells at a time with one independent variable. F-tests and t-tests are similar. Again, in the literature, they'll probably say ANOVA. We're going to just talk about one-way ANOVAs, which means you have one independent variable with 2 or more values. So we were working on trying to come up with 2x2 factorial designs. Remember, you're going to do that. Now here is just a small little table, again with my sample I had with the injection drug users in St. Petersburg, Russia. And what came out as far as a statistical result? I was looking at a couple things. One is how many times you were treated for an STD, and also how many HIV positive people do you know. Now it's probably not brilliant here, but the second one, the number of HIV positive people known, the folks who indicated they were HIV positive had a statistically significantly higher number of HIV positive acquaintances, and that number there's the average, so over 9, versus if they're not HIV positive, they're didn't, they knew less than one person. But you see the S statistic where it's 89.5 for the statistically significant p-value of less than 0.001, whereas the other, which I was looking at number of times with STD treatments, which aren't statistically significant, p-value is 0.53, and the F statistic is only a 0.38, and that's the kind of thing you see. So you see the logic of it. It's all makes perfectly logical sense with the statistics and the p-values. So what do we have to remember? Specifically, I want you to remember social versus statistical significance. You can achieve statistical significance relatively easily, oftentimes. And now we can call it a day with this. And feel free to contact me with any other questions. Signing off.